Hello guys, welcome back to Quadratic Functions. Here we are going to explore pretty lot of stuff, so be ready for that. But before we start doing, I want to say a very thanks to you guys for your support, for subscribing, being subscribers to my account. So I really appreciate what you're doing, and actually I try to also put lots of efforts in order to satisfy your needs in math studies, and probably after maybe a year I'll start new science, what is called physics, and actually I think will be very useful for you guys. So but now maths, and let's get started. So we explore quadratic functions, and today I want to show you what vertex is for every single quadratic function. So basically vertex is the minimum or maximum point. So if you have a look at general graph, for example, y equals x squared, here is the vertex, the very minimum point. If your parabola turned upside down, so means branches downward, so the vertex is going to be the maximum point. So basically the vertex is the turn point of every single parabola that you have. It doesn't matter where, it might be even here, so the vertex is going to be the minimum point for that. If it turned upside down, so the vertex becomes the maximum point. All right, I hope you understand in general. And because vertex is the point, it should have some coordinates. Okay, so for simplicity, first of all, I just remind you that quadratic functions is or has the general form x squared plus bx plus c, and just I highlight coefficients. So this is the general form, and this is the general quadratic expression for the function. All right, here I'll just give you shortcuts how to find vertex in a pretty straightforward way. So the vertex is, I put V as the point. Let's say it has x vertex coordinates and y vertex. Later on, we'll understand how it's connected with coefficients. Okay, so right now I'm gonna give you shortcuts how to calculate the vertex coordinates very fast manner. You just simply use a, b, and c coefficients. In order to define x vertex, you need to take negative b and divide it by 2a. So also, in order to find y vertex, you just need simply to put this x vertex in the function in order to define y vertex coordinates. Okay, so I'll give you a very interesting example for that. Let's say we have quadratic function y from x. That's an example how you can find vertex. So y from x, let's say it's x squared plus 3x and plus 2. Okay, so let's find the vertex for this parabola. First of all, let's calculate x vertex according to the formulas. So I just simply put them so that you make sure you understand how to do that. I don't explain why, just here's a given shortcut, so you can use that. Later on, I'll definitely show you why is it so. Okay, so we on vertex. Okay, and right now we just need to calculate x vertex coordinates according to the formula negative b over 2a. So in our case, b is 3, so we'll take negative 3 and divide by 2 times 1 because a is 1. Okay, so we have negative 1.5. All right, so we've got a vertex, but I will use this value because it's fractional and it will be convenient for this expression. So right, what I'm going to do next, I just simply put this value negative 3 over 2 inside y, instead of x, inside of y, in order to define y vertex coordinates. So y vertex is simply a y value from negative 3 over 2. And where x stays, so just simply plug here and here your value negative 3 over 2. Alright, so first is negative 3 over 2 squared. Then I just simply add 3 times again negative 3 over 2. And finally I add 2. Okay, so if I calculate that, I'll get the following. Y vertex is 9 over 4. Then 3 times negative 3 is negative 9 over 2 and plus 2. So if you add 9 over 4 and subtract actually 9 over 2. So what I'm going to do, I just multiply by 2 in order to align denominators, and I'll get finally negative 9 over 4, and finally plus 2. So the final result will be, instead of 2, I'll just use 8 over 4, I guess. Yeah, that works. So plus 8 over 4, and I'll get simply negative 1 over 4. Okay, that's the vertex coordinates. So we can put y vertex coordinate as simply negative 1 over 4 or negative 0.25. As you can see, it's pretty fast, and you've already got the vertex coordinates. So why you need the vertex? Obviously, it will be easier, for example, if in questions and problems where you're supposed to plot the graph of the parabola, it's much entirely required either to have specific vertex form in order to get the vertex automatically, or using this shortcuts, you can do it much faster without completing the square, go to the vertex form, especially if you're given already the general form of your quadratic function. And so the question was why you need to use the vertex coordinate, why you need to calculate. So if you calculate the vertex, first of all, you know the line of symmetry. So because the vertex actually, if you just practice here on this parabola, let's say the vertex here, so the line of symmetry goes through the vertex. In this case, it's y-axis, it goes down, so that's why your vertical axis of symmetry is already defined. So it has an equation x equals x vertex coordinates, and so you know if your parabola is somewhere here and you know the vertex, you already know the axis of symmetry. So it's powerful and it's required. Also, you can align all the values around your x vertex coordinate. For example, in our case, as we calculated, we've got negative 1.5. If we want to create this set of data in order to get points, right, for plotting the graph on Cartesian plane, so you simply know that negative 1.5 is sort of central point, is a median, and you can center all the data around the median. Okay, so for example, you can have a step 1 and you simply subtract 1 and 1 more time, and also you can easily add 1, so we get 0.5, 1.5, and 1 more, let's say 2.5. So all your data is symmetrical around, it should be symmetrical around negative 1.5. And if you start calculating y values, so here is going to be the vertex, negative 0.25, that's y vertex coordinates, and all your data will be symmetrical around your value for the vertex. So actually, this sort of a median, and you can center all your data. So that's why you know where to start from and how symmetrically to distribute your data around the vertex. Okay, so I hope you understand how it works. Why we need vertex, I'll tell you a bit later. So when we have combined transformation, and now we start thinking about the vertical and horizontal translations. So what it means, we have the vertical translation by k units. Just remember transformation theory, okay? If we have vertical translation by k units, just remember what was happening with triangle, with some 2D shape. You simply lift up by k units up, all right? So what it means you lift every single vertex of your object, of your shape by k units, right? If it's going to be k is positive, so you lift it up. If it's negative, you lift it down. Here is the same story, and that's why I decided to tell you a few words about the vertex and how to calculate, because it's better to keep track of the one single point of the parabola, and this single point is the vertex, okay? It's much more convenient to keep track where your vertex goes during translation instead of choosing some random point. and trying to like restore a parabola from that. It's much easier if you know the vertex and you can easily restore your shape. Because during translation, remember, during translation, your shape is not changing, okay? That's the key feature of the translations. And during horizontal translation, this is also the same. You don't change the shape of your function or your object. Okay, so let's get started. And first, what we're gonna do, we'll do the vertical translation by k units. So how it looks like in terms of function. We always start from the basic function y from x equals x squared. And then we simply want to figure out what new function, let's say g from x, what new function will look like. Okay, in previous videos, we also get some scaling procedure, right? It was transformation. During transformation of the scale factor, the shape is actually changing. Remember, you notice that the shape is like stretched vertically or like shrink, and this is the same fair for horizontal stretch or shrinks. So in this case, we don't have any change. We simply need to move your vertex coordinates and the vertex point by some k units. In this case, it's vertically, so what it means, what we're gonna do, we need to take your basic function and simply add k units. Okay, so as you understand, k might be positive or it might be negative, or so that's why when it's positive, to every single value for y, for your basic function, we simply add k units and it's positive. Okay, so we shift it upwards. Okay, if k is negative, we shift it downwards. So that's why I just simply put what actually happened with the graph. So k units down. In this case, of course, -3 means -3 units down. Okay, and here in this case, it goes up by the same k units. Okay, that's how it works. And now let's explain what actually happening. So you have your g function, g from x, is simply your x squared and plus k. For simplicity, I'll take k equals, let's say, -2, and I just want to calculate what will happen with your basic parabola if k is equals -2. All right, so what we're gonna do, we just create the table for x values. So I'll create for just let's take -2, -1, 0, 0 is the vertex, 1 and 2. Okay, we've got x values. Now we also need to have your basic parabola y from x, which is x squared, and also g from x, which is in our case, when k is equals 2, in our case, g from x is simply x squared minus 2. Okay, so we have the pattern and we can work with that. So that's your g, but first we need to say what y values for y function for your basic parabola. Okay, so -2, as you remember, you just square it up. It's 4, 1, 0, 1, 4. That's symmetrical, and I simply highlight the median. Okay, it's here. So next, for g function, I put the green color for that, and for g, what we're gonna do, we simply need to subtract k. Oops, I actually didn't plug the value for k, so I want to do that right now. So we have k equals -2, so it's -2. Okay, so right now what we're gonna do, we just simply need to subtract 2 units from your previous or basic values. Okay, so 4 minus 2, it's 2. So 1 minus 2 minus 1, here is -2. And the same we will have for positive x values. So 1 minus 2, it's -1, and 2 again. All right, so we've got the points. And because we've already got the points for basic parabola, let's just simply subtract visually, first of all. I just want to use this formula as x squared minus 2, and simply for a given value for like our basic parabola, I simply subtract 2. Okay, so let's do it. First of all, we have 1 for y, I subtracting 2, and in this case, so green, I use green markers, we'll have all the points goes down 2 units. So from level of 1 for y it goes to 0 and 1 more because 2 units down. So we'll get simply -1 value. Okay, so let's check it. For -1, we'll have -1. That works. And for 1, we also have -1. All right, so what about the next markers? So we have level 4, and we simply subtract 2 units down. So we're subtracting 4. That's when x equals 2, so that's why we arrive 2 units down. So from here, we just go down 2 units. From here, we go down 2 units. That's how it works. So you can actually, you're not need this table. I just show you that you can either use the table or use just manual subtraction from the graph if you're already given that. It's much easier. If you're not given the graph, for example, you need to plot, so I recommend to use the table for x, for your basic parabola x squared, and for your new g function that is translated k units vertically. Okay, in our case, k equals -2. Okay, so and for, yeah, and that's it. For what about 0? So 0 goes down by 2 units. So actually from 0, the vertex falling down 2 units. Okay, so that's the vertex. We actually can highlight the vertex where it was originally. So the vertex had coordinates 0 and 0, right? It's in the origin. But right now, the vertex has new coordinates. What about translation? It was the vertical translation, so you will have the change in value y, right? So it just dropped down by 2 units. 0 for x stays the same, and actually it happens in reality, so it doesn't move anywhere. So, okay, let's connect and we'll get the simple graph for your parabola, which is now, okay, I'm trying smoothly to connect. Sorry for, because I do it manually. Sorry for that. Okay, actually I'm using the phone to create the video, and right now I'm writing on the phone screen on the top of that. Okay, so anyway, we put the parabola down 2 units, and we notice that vertex has changed that y coordinates by 2 units. All right, so that's how your graph will look like. So one more time, vertical translation by k units lead to vertical shift with no changing in the shape. Okay, that's crucial. All right, so if k is positive, we just lift it up. That's pretty easy. Okay, so let's go to the second part of the translation. It's horizontal translation by h units. Okay, so that's horizontal, and what it means that you will have shift to the right or to the left. So right now I'm just gonna give you a ready to use tool how to define that. Okay, one more time. So h units and h units. Okay, so how to define where exactly it will be moved. So I'll give you the next steps how to work it out. So our basic parabola is simply x squared, y equals x squared. Okay, I'll give you the ready to use formula. G from x, that's translated function, so it was translated by h units. I highlight h, so h units horizontally. All right, so and how it looks like, you simply need, that was y from x, right? I put the argument denoting that y was depending on x. So g from x, if it was translated by h units horizontally, should have the following pattern: x plus or minus h. And if you actually put this new argument, So you simply can put this argument where instead of argument for x, so basically instead of x, you'll have the following. You'll get x plus minus h, which is squared. That's what you're actually going to have. So one more time, g from x will have the following form, plus or minus h squared. Okay, now the reasonable question, how to define which sign to use if it was translated, for example, to the right, or actually, for example, you're given expression for your translated function, how to define where exactly which sign, where was translated. Okay, so we have like two questions. If you're given already expression, let's say x plus h, you need to be ready to answer because you might be asked to draw the graph, right? Translated graph G. And that's a reasonable question. Having that, how to define where exactly it was translated, to the right or to the left by h units, and vice versa. If you're given the graph that's already, for example, here is shifted to the right by h units, you need to be able to say, okay, what's the formula states for that? Okay, here I'll show you how to do. Okay, so guys, just remember I told you that we need to keep track on the vertex. In this case, we have the vertex where? We have the vertex with the coordinates 0, 0. Okay, so that's the vertex point. Okay, so if you have a translation and your vertex becomes, let's say, somewhere here on 5. So obviously new vertex of the function g will have the following coordinates 5 and still 0 because it was translated horizontally. That's new vertex. Okay, so guys, please tell me if the vertex has the coordinate x equals 5, how it's related to the formula. Should we put x minus 5 or plus 5? So let's consider that it was translated 5 units to the right from the original position. 5 units to the right to the original position, from the original position. So how actually, which sign to use? You just need to think as if you have this expression squared, so that if you have 0 here in the brackets, you'll get your g from x equals 0, because the y vertex coordinate should be or should have 0 value, right? That's for vertex. That's for vertex. Okay, so because you definitely know that x vertex coordinate should be 5, you need to put 5 here instead of x and ask yourself, so when you put x vertex equals 5, you'll get 5 something, some operation plus and minus squared. So right now you don't know, you just put plus and minus. And you need to define for which operation delivers you y equals 0. In this case for g function, so g vertex equals 0. Obviously subtraction, okay? That's the fast track how you can easily just remember. So instead of plus, we take in the minus. Because definitely when we plug 5, we need to have 0 in the brackets in order to get g vertex to be 0, okay? Otherwise, it will be like other value different from 0. So that's why we will be using x equals 5, and that's why we will choose negative sign. So, outcome here. We use g for x equals x minus h when the graph shifted h units to the right. Okay, to the right. So that's the horizontal shift by h units. So make sure you understood this moment. That was actually details that you need to be aware of. This is sort of hint. So many students trying to remember, okay, x minus h is to the right. But sometimes you might forget. That's natural for a human being to forget those details. So that's why, guys, this is the testing tool for you. If you just forgot, you just need to put x vertex equals 5 and be aware of that you'll get g vertex equals 0. So obviously it was plus, you wouldn't get g vertex equals 0, okay? So 8 h units to the right. And vice versa, if we have x plus h, that will be h units to the left from the original position. So that's sort of the rule that you need to remember. That's very significant. You can even like print screen, try to memorize, but also keep in mind that you'll be able to check it. Okay, so that's why it would say that it was shifted 5 units to the left instead. So if it's to the left, now new vertex might have this coordinate. I just simply show you it's -5 and 0. And according to the operation, how to get again y vertex equals 0 for new function, so simply g vertex from x vertex, how to get 0, you need to get, instead of x you put -5, and in combination with 5 it should be 0, so obviously you need to plus that. So this is in full correspondence with this rule, okay? -5 instead of x vertex plus 5 should give you 0. Okay, so hope you understand that. And I'm not gonna like draw the graph, so maybe I'll sketch fast. Let's say we need to sketch this graph, x minus 5 squared, and we simply, I'm not going to create the table, I just do create the sketch and that's it. So simply I stick to the same pattern. From here it should have the same like points, like 2 units again and 4 units the level for next one. So somewhere here, and I just simply connect that. All right, that's your parabola with no change in the form. So it was shifted h units to the right, in this case plus 5 units to the right horizontally. Okay, so make sure you understand that. Okay, now we'll go to next point, graph in the form of, okay, actually graphs in the form of, I think, vector of translation, so that's why it should be like combined transformation. So we're simply trying to combine two transformations in one. So we're going to use h horizontal shift and k vertical shift. So if this is your basic parabola, that's x squared, so your new g function, which was translated h units and k units, so h horizontally and k units vertically, I just put that vertical translation, and here's horizontal. So what general equation for a change function we will have? Simply we need to say that it's y from x plus minus h, right? And also to that value on the top of that, we need to add some k units externally. So that means in general form, we'll have g from x equals x plus minus h squared and plus k. That's the general form of vertical and horizontal translation, so basically combined translation. And having that, we can simply say that if we have, let's take for simplicity, we have h equals let's say 5, that's horizontal shift, and let's say k equals -2. So let's keep in track of on the vertex. We have the vertex, oh yeah, h equals 5, so 5 units to the right, because we need to mention where exactly to the right. Okay, so 5 units to the right, and k is self-explanatory, so -2 means it goes down, that's to the right. Okay, so we just keep track of the vertex. Let's see what will happen with that. So initially it has the coordinates 0, 0. Yes, it was in the origin. And now let's see where it will be. So new vertex should have the following coordinates. So it will have 5 as new for x and -2 as new coordinate for y. So that's new vertex for the function g that actually has this form. Okay, so what we're going to do, we just need to put this new point of the vertex on the Cartesian plane and see where new parabola will start off. Okay, so 5 units to the right, I simply use vectors in order to show direction of the shift. So we have 5 units to the right from the origin, and I will use red color to denote that we have 2 units down. Okay, so from that point we just combine transformation and we put 2 units down, so it should be somewhere here. All right, that's the new vertex coordinate. Okay, I'll use the blue color for parabola, so that's our vertex, and now it has the coordinates according to what we've got. So 5 and -2. So from here, we just need to restore our shape. The shape is not changing, so I'll try to do it very carefully for not to spoil the draft and my picture, my beautiful picture here. All right. So let's pretend that it's sort of symmetrical. So by the way, new axis of symmetry will go through the vertex coordinate, and it will be vertical, of course, because it should go only vertically. Your parabola is not turning. So that's why the vertical line that goes through x equals 5, and that will be the line of symmetry. So the line of symmetry. Okay, so that's how it works. Here you can figure out the new vertex coordinates, and here is the rule of combined translation. So in order, so you heard the new word, you heard a new word probably here, vector of translation. Just remember transformation theory. We also had this term before, right? When we translate different shapes, we shifted like some units to the right, let's say some units down or up, and finally we'll get the final position. So this is the same as the vector of displacement. So guys, who knows physics? That's also self-explanatory. So we just use the black color in order to connect the original point where there was vertex originally with the final point where now new vertex for your g function. If you connect with the vector, yes, one more time, just correct that, sorry, more straight line. Okay, that's your vector of translation. So you can put the letter V to denote this is the vector of translation. You can depict it here. So vector of translation. So as any vector, we can use the vector of translation. It was basically, it shifted parabola 5 units to the right, so that's why 5 is positive, and -2 units down. So simply as any vector, this is x coordinate of the vector, and this is y coordinate. Okay, so simply in the questions, when you are asked to transform or translate your parabola using the vector of translation, so this is the vector of translation. If you're given coordinates for that vector, make sure you correctly write the algebraic formula for the new parabola. So let's practice. When we have 5 and -2 new vector, so let's see how your new equation should look like. Okay, we translated 5 units to the right, so that's why your equation for g from x should look like as x minus 5, right? Squared. That means we translated 5 units to the right. So here is the minus. Be careful. Here is the minus because minus tells you it's shifted to the right. Okay. While here 5 stays positive because 5 it's positive for x shift. So x coordinates should be positive for the vector. And let's see exactly. So x coordinates is simply the coordinates of that vector, the length of that vector. It's positive, it's directed along x-axis. So here is negative, so because this vector goes in the opposite direction for y, so it should be negative. And -2 tells you that it goes 2 units down. Okay, so that's why in the end we also subtract 2. Okay, so make sure you understand that. So that's why the general form of the translation using vector of translation will look like the following. So we'll take, if we have vector translation with coordinates h and k, we simply can write translated function in the following manner. So we'll get x, we subtract h, we square it up, and add k. For example, let's take another vector which has -2 units, so means 2 units to the left, right? And let's say 3 units up. So I just put the arrows in order to show you that it was translated 2 units to the left and 3 units up. Okay, so guys, in this case, how would you write your general equation of the function, of your quadratic function? So you just simply put x in the formula, x minus, and instead of h, you take in -2. So in your case, parameters are h is -2 and k is 3. So just simply put negative, and -2 becomes +2, okay? Then squared, and then you add 3 as just simply you add 3. So in this case, your parabola was shifted 2 units to the left and 3 units up. Okay, so make sure you understand that was vertical and horizontal transformation. Okay, so we've got the last point here, not the last. We also have the GCSE problem in the end. I guess we need to stop and let's say, because information need to be given in like small pieces, so it's pretty enough. I just covered translation theory here in really lots of details. So that's actually, if you quite good with that, so try to stop and pause the video and try to first describe graphs in general form. So what I mean in general form, I mean that the general form for the parabola is standard equation x squared, so plus bx and plus c. Okay, that's standard form. And actually here my purpose is to tell you how to come to the vertex form. So from general form into the vertex form that we're supposed to have in the next video. And also I'll tell you how to resolve this problem. So for someone who wants to do, just pause the video trying to do by your own, and in the next video you'll see my solution and my explanation for that. Okay guys, one more time I want to give you thanks. I want to give shout out for new subscribers. Thank you guys, you support me and I really enjoy that. And so my pleasure to you for joining like our educational course. I hope maybe within a month I'll get more or less like all videos necessary for GCSE examination and also for GCSE extended. So I'll just fill up my video set with statistics and probability. Also, I add some topics for geometry. Also, I consider trigonometry, and that will be done, I think. I'll try to do within a month so that you can pass your like final exams that which are probably in summertime with no problems. So the earlier you start like learning, learning with me, practicing by your own, practicing with me, doesn't matter. So actually you'll have great chance to get the A and A star. Trust me, I'll give guarantees for you. If you are a detail watcher, you'll definitely succeed in your examinations. Okay, thank you guys, and peace out.